What is Faraday's first law? The amount of substance deposited is directly proportional to quantity of electric charge. Formula W is equal to E by F into I into T. Okay. See second law. Take sulfuric acid in one cell, AgNO3 and copper sulfate solutions. All are aqueous solutions only. These are electrodes. Battery. See, what is common thing in this? Battery is the common. We are passing same amount of current into three cells. We used only one battery, so same amount of current is passing through three different electrolytic solutions which are connected in a series. Okay. According to Faraday's second law, when same amount of current is passed through different electrolytic cells which are connected in a series, then weights of substances deposited at electrodes are in the ratio of their equivalent weights. When same amount of current is passed through different electrolytic solutions, then weights of substances deposited are in the ratio of their equivalent weights. W1, for example, let us consider W1 is weight of hydrogen, W2 is weight of silver, W3 is weight of copper. W1 is to W2 is to W3 is equal to equivalent weight. E1 is to E2 is to E3. See the definition. When same amount of electric current or electric charge is passed through different electrolytic solutions which are connected in a series. Then weights of substances deposited are in the ratio of their equivalent weights. Take the above diagram. For above diagram, weight of hydrogen, weight of silver, weight of copper is equal to equivalent weight of hydrogen, equivalent weight of silver, equivalent weight of copper. This is for above diagram. But for generalization, what we can take? W1 is to W2 is to W3 is to and so on. W4 is to and so on. E1 is to E2 is to E3 and so on. That is generalization. This is for above diagram. So in generally, we can write like this. W1 is to W2 is equal to E1 is to E2. And so on. Actually, we can write another two values also. W3, 4 also we can take. This is for generalization. From this, tell me W1 by E1 is equal to W2 by, can we write like this? This is Faraday's second law. Faraday's first law is very important and we completed questions also on it. This is Faraday's second law. I'll give you one question also based on this. Is screen clear? Note down one question. First year students give what and yeah. Aisha, Zubair, Obed not attended today. Surobi. Right. Three Faradays of current is passed through. Is passed through. Aqueous CuSO4, comma, aqueous AgNO3 and aqueous AuCl3 called AuCl3, which are connected in series. Which are connected in series. Then find ratio number of moles of copper, comma, silver and Au. This is one important model question on Faraday's second law. Can you try Julie? Did you listen? This is previously. You can try, second year students. Here, see, actually, no need to use equivalent weight, but that sentence is useful for us, connected through a series. We no need to use any equivalent weight. Questions are different based on that equivalent weight concept. Okay. Generally, equivalent weight for elements is atomic weight by valency, right? But here we don't use that formula. But why I given this question? Here one important statement I given, connected through a series means same amount of current is passed, right? General question only. This is like a stoichiometry relation based. For 1 mole 1 Faraday, 2 mole 2 Faraday, like that. Right. First of all, write the equation. Equation for first one. Copper sulfate solution. Copper sulfate dissociates into Cu plus 2 and SO4 minus 2. Take copper plus 2. You tell me, to deposit 1 mole of copper, how many moles of electrons we should use? What is the charge on the copper? Plus 2. So to get 1 mole of copper, how many electrons we have to write? 2. 2. So 2 moles, 2 electrons. Right? 2 electrons, 2 moles of electrons here. 2 electrons means 2 moles. Mole terminology. According to stoichiometry, we consider moles only, no? Stoichiometric coefficient. 1 mole, 2 mole, 1 mole, like that. Right? You tell me. When we use 2 moles of electron, how many moles of copper is depositing? 1 mole of copper is depositing. 1 mole of Cu is depositing. Right? Right. In the Faraday's first law given, 1 Faraday is equal to how many moles? 1 Faraday is equal to how many moles of electron? 1 Faraday. 1 mole of electron. 2 moles of electron means 2 Faraday. See, in place of 2 moles of electrons, we can write 2 Faraday. 2 Faraday is producing. Means when you pass 2 Faraday current, 1 mole of copper is depositing. Correct or no? So 2 Faraday current is depositing how many moles? 1 mole. 1 mole of copper. But in the data, see, how many Faradays are given to us? 3 Faradays are given to us. Correct or no? 2 Faradays is depositing 1 mole of copper. But in the question, how many moles are given to us? Sorry, how many Faradays are given to us? 3 Faradays. So cross multiplication. Do cross multiplication. 3 Faraday is equal to, Sweta, tell me, X value. 1.5. In terms of fractions, please tell me in terms of 3 by 2. 3 by 2. So X is equal to 3 by 2. 3 by 2 moles of copper. Remember this value. Because we have to write the ratio. After getting all the moles, we will put in the simplest ratio. We will remove the fraction by multiplying with suitable number. Can you do similarly? Remaining. I did for copper sulfate now. Can you do for AgNO3? For AgNO3. Same, write the equation. Ag plus and NO3 minus. Second solution, AgNO3. Kirti, Ketara, are you following, girls? Ritika, Misbah. Next, second solution. Aqueous AgNO3. Aqueous AgNO3. First part is over, second part. AgNO3 dissociates into Ag plus and NO3 negative. Important model question. Listen carefully, all of you. Take Ag plus. Tell me, to get 1 mole of silver, how many moles of electrons we have to add? Just see the charge. How many positive charges are present? 1 positive charge means 1 mole of electron you have to write. Right? 1 mole of electrons are depositing 1 mole of silver. 1 mole of silver. Just see the charge. Based on the charge, we have to write the number of moles of electrons. If the element contains 2 units positive charge, you have to use 2 moles of electrons. If element contains 3 units positive charge, you have to use 3 moles of electrons. 3 electrons means 3 moles of electrons. Right. 1 mole of electron means according to first law 1 Faraday. 1 Faraday is depositing 1 mole of silver, 1 mole of Ag. Then 3 Faraday, 3 Faraday 3. 3 Faraday 3 mole, sorry. 3 mole. 3 mole of water. Easy. Next, last one. Last one. One more. Last one. How to dissociate AuCl? Last one. AuCl3 gives rise to Au plus 3 plus 3Cl minus. Take Au plus 3. Au plus 3 gives rise to Au. To get 1 mole of Au, how many moles of electrons we have to write? 3 electrons. 3 electrons means 3 moles of electrons. 3 Faraday, right? Directly. 1 mole of electron, 1 Faraday. 3 moles of electrons, 3 Faraday. So 1 mole of Au. You no need to do any cross multiplication because in the question 3 Faraday given, here also 3 Faraday. So no need to do any cross multiplication. But finally we have to arrange the moles in the simplest ratio. Okay. What about copper? How many moles of copper we got? 3 by 2. This is the ratio. Ratio first, what we taken? No. Copper. Copper is to silver is to Ag. Is equal to 3 by 2 is to 3 is to 1. With which number we have to multiply to get a simplest value, simplest ratio? With 2. Multiply 2 with 2. 3 is to 6 is to 2. This is our material question only, direct level 2 question. Okay, next keep adding electrochemistry 2. We'll do numericals after completing this iterative because the worksheet is mixed. Electrochemistry 2.